try to figure out this bad boy or girl, depending on how you feel about geometric figures. Um, these are all equal, so this is an equilateral triangle. You might have to do something a little special, like, obviously it's circle minus triangle, but this might give you a hint what you might have to do for this. All right, to figure out, what's going on here. Oh, and then this, and then what kind of triangle did I just make right here? And then what does it do to the, blah blah blah. Okay, so I'm gonna leave that alone. It has to do with 30, 60, 90s. All right, and then I'll see if someone can figure that out. Gave you too much information. All right, area of a regular polygon. It's half apothem times perimeter. Okay, so this one's special. I'll set this one up and see if you can finish it off. This looks like it might be a square. I think it was supposed to be, so you're going to have to count it as such. I think I distorted it, so I should have marked that as such. Otherwise, you really can't do this, because since I made it a square, then this makes this a 45, 45, 90. So this is 4, so this is 4. All right, so I guess what I'm trying to do is apothem times perimeter, but really it's kind of over. If this is 4, this is 4, which makes this 8. So it's really just 8 by 8. So it's 8 times 8, which is 64. So I did unit square. I did use a little 45, 45, 90 on that one to figure out what was happening there. This one I am going to go through because this is not an apothem. So what we need to do, first of all, it's 1, 2, 3, 4, 5, our typical hexagon, and we do want to call it a regular hexagon. So if I draw this one from there to there, then this angle is 60 degrees. So then what I have to do again is drop this perpendicular, the apothem. So that makes this 30, and then this is 60, and then this is 90. So 4 is the 90-degree side. That makes the 30-degree side half of that, 2. The 60-degree side, easy for me to say, is 2 root 3 then. A root 3, 2, or 2 times A. So A root 3, 2A. That's what I was trying to say again. So if this is 2, this is 2, because an apothem cuts this in half. So this whole side is 4. Only in a hexagon is the radius, which I did call that on another slide, is equal to any of the sides in a regular hexagon. Sorry. So it's half apothem, 2 root 3, times perimeter. There's 6 of these sides, so 6 times 4 is 24. So actually half of 2 is 1, so the exact answer is 24 root 3 units squared. Feel free to rewind the video and watch that again if that just blew your mind. So try to do something similar with this one, again a hexagon, and then try to figure out that one. What you need to know about this one, sorry for speaking weird, but actually you don't need to know much. It is equilateral though, probably have to give that away. Because it's a regular polygon. All right, and I guess I do say that in the beginning of those. Find the area of the regular polygon. So these are all regular. So that's why this was a square even though it was distorted. So regular polygon means all of these sides are equal. All right, so you got some triangle work on that one, and then this one, you should be able to do. Okay, then last but not least, stop sign. This is an octagon. So give this one a whirl. We'll discuss this one maybe in class. Quiz shouldn't take too long. Holy crow, what is this thing? All right. I'll just give you a hint on this one. This one I'll probably do. That's a bunch of circles, isn't it? So this is square minus circles. Holy cow. All right, that's how you find the area of the shaded region, if you can tell. Hopefully in the printout you can see that this is what's shaded and then this is open. 1, 2, 3, 4, 8, 12, 16. There's 16 circles. So this is what you could do. This is 32 as well, from here to here, to here, to here, to here, to here, to here, to here. So divide that by 4. I think that's 8. That means each diameter is 8. 8, 8, 8, 16, 24, 32. Pretty sure about that. All right, that means each radius of the circle, by the way, there's 16 circles, 4, 8, 12, 16 circles. Each radius is 4. Okay, so that's nifty about that one. So it's 32 times 32, area of square, minus the 16 circles. All right, so what's this one? This one is area shaded region, rectangle plus triangle. Try to figure that out based off of what's given. All right. I think you can go standard on this one, like, maybe there's some information that allows me to find this for the rectangle. What? Triangle. All right, let me see. What's this? Looks like someone peeking over a wall there looking at you. Little weirdo. All right, but anyway, this is a semicircle. So this is half of a circle minus a full little circle. See, because if I put this white with this white together, that's a full white circle. So we have half of a big circle minus what really turns out to a full small circle if I put these two halves together. All right, so so what's half of the big circle? The big circle, we got to be careful how this is labeled. This is 2 centimeters right here. If it was in the middle, the whole thing would be 2. So this is 2, 2, 2, 2. All right, so the radius of the big circle is 4. And I'm taking half of that because it's only half of a circle here, all right, that you're dealing with. All right, and let me just leave that. Minus, now again, when I put this together with this, it's a full circle. And the radius of that circle is 2. So 2 squared pi. All right, now you may think these should be the same. No, 4 squared is 16 first, then half of 16 is 8. Minus 4 pi. Now, the exact answer is 8 minus 4, which is 4 pi. All right, and that is centimeters squared. All right, and then you can get the approximate by typing on your calculator. Then last but not least, again, I'm going to have to cut this video in half because I have a 15-minute limit. What in the world is going on here? This is dizzying, and I'm going to faint and hate Mr. Samuelis on these questions. It's so difficult. So you got to come up with a plan here. All right, so here's why I'm going to go through this one. This is a trapezoid. So I could just find the area of a trapezoid. But I can't because I don't know that top base. All right, that's a lie. I actually do. So I just made a fool of myself. Because on the inside of this drawing, this is a parallelogram. All right? So actually, the fastest way to do this one is, I know that top base is 32 feet. All right, because of what I've just highlighted here. On the inside of this, there's a parallelogram. Opposite sides are equal. But then I'm going to erase this again, and then highlight this now. That's a trapezoid. So that's what I'm going to find, the area of the trapezoid. Because the bottom base is those 3 sides added together. The top base is that. The height of the trapezoid is 23. It's all over. 1/2. Big base, oh boy, here we go. I got to add 32, 42, 52, 56, 60, 74, I hope. And then times 32 feet, and then you could type that on your calculator. So you just got to look at the drawings and figure out what you got and then go from there. All right? All right. Miss you guys. I'll see you Tuesday.